Okay, this is the November 2020 Matric Paper 2 question on galvanic cells. It says the electrochemical cell illustrated below is set up under standard conditions. Remember, these are all equilibrium reactions, so everything is set up under standard conditions of the pressure of the gas, the concentration of the solution, and the temperature. It says component X completes the circuit in the cell. Here's component X. It's obviously the salt bridge. It says state one other function of component X. So component X is completing the circuit. So the external circuit has electrons flowing when component X is completing the circuit by providing a path for the movement of ions. So when the ions move inside the solution here and inside the solution here, the ions in the salt bridge replace them so that there is electrical neutrality in the cell. Because obviously you can't just be having electrons disappearing into thin air. Then it says define the term anode. So an anode is obviously an electrode. Okay, so the anode is the electrode where oxidation takes place. So the first thing I always remember with this topic, before I start, I always write oil rig, red cat. And then I remember that oxidation is loss of electrons, reduction is gain of electrons, and reduction always occurs at the cathode. So the anode, to identify the anode, I need to look for the electrode where oxidation takes place. So in order to determine where oxidation is taking place, you have to look at what's going on in the two solutions there. And you can see on this side, we've got platinum and a proton and hydrogen gas, and on the other side we've got a magnesium and magnesium 2+ ions. So you go to your table of standard reduction potentials and you find these two reactions. You look for whatever you've got there, which is magnesium and hydrogen, or you look for the proton and the magnesium ion. And so I've just clipped them out of the table here so you can see them. And if you have a look here, what is going on with the electrode potential value? If you have a look, the one with the most positive value is going to be the reduction reaction, because obviously in that table, all the forward reactions are reduction reactions. So the one with the most positive value is the reduction reaction, which here is the hydrogen, okay? And here the hydrogen is gaining electrons, a reduction reaction. So we are looking for the oxidation reaction, which is the magnesium 2+ and the magnesium reaction, but this is going in the opposite direction because it's the oxidation reaction. And that means, what is my anode? It's the actual electrode. It is magnesium metal. You can see with the hydrogen, which is the cathode, the hydrogen cathode has to be platinum because you can't be completing a circuit with hydrogen gas. Then it says write down the reduction half reaction that takes place in the cell. So we've obviously just figured out which is the reduction and which is the oxidation reaction. So the reduction reaction is the one that is taking place, the forward reaction. So it is 2 protons plus 2 electrons going to hydrogen gas. Please write this with the single arrow because the double arrows indicate both an oxidation and a reduction reaction. So you need to prove that you know which is the reduction reaction. It's the reaction with the gain of electrons, and you must put the single arrow. Just copy it off the table, but with the single arrow, and make sure it is a reduction reaction. Now it says to you, write the name or formula of the reducing agent in the cell. And so because electrochemistry is what it is, the reducing agent is oxidized. So what is actually oxidized? When you look on the table, the oxidation reaction is a reverse reaction. So it has to be this magnesium over here that is oxidized. So if you are oxidized, you are the reducing agent. So it is Mg or magnesium. Now it says calculate the initial voltmeter reading of this cell under standard conditions. So you go to your data sheet and you find those formulas, and then you just pick whichever one you like, and then you copy it exactly 100% exactly as it is off the table. So I like this one because we've been talking about reduction and oxidation. You copy the formula exactly like this, and then you say to yourself, which was the reduction reaction? We saw that was, which we wrote it here, the reduction half reaction. It's the hydrogen reaction. So this one has a value of 0. Show your substitution. And then we are subtracting. What was the value of the magnesium reaction? It was minus 2,36. So then if you put this in your calculator, a minus and a minus makes a plus. And remember your unit, this is in volts. So this is what the voltmeter will read initially. Now they say to you, we took out the magnesium, okay, and they put copper. So now, instead of having magnesium on the one side, if you have a look here, what have they done here? They've taken this magnesium out, and they have come, let's have a look here, let's change the pen color. They have scratched out this magnesium, and they put a copper electrode, and they made a solution of copper 2 plus ions. So we've still got copper, and we've still got the platinum and the hydrogen on this side, but now on the other side, we've put copper. And they've said it's found that the direction of electron flow changes. It says explain fully why there's a change in direction of electron flow by referring to the relative strengths of the reducing agents involved. So now it's obvious if you look at the table. I'll show you the whole table now, but if we just look at the copper reaction, can you see Cu2 plus 2 electrons goes to copper, has a positive value, whereas the magnesium reaction had a negative value. So this one, the reverse reaction is favored. This one, the forward reaction is favored as compared to hydrogen, which is, as you can see, 0. Okay. If you want to answer the question exactly how it says with the strength of the reducing agents involved, you need to go to the table. If you don't know what's going on, you can go to the table to get help. First of all, what is the reducing agent? The reducing agent is the thing that is oxidized. Okay, so we have to identify what is being oxidized. And on the table, if we have a look at the table, on the right-hand side of the table, there is written on the side here, increasing reducing ability with an arrow and increasing oxidizing ability also with an arrow. So that means if you follow the arrow on the right-hand side, increasing reducing ability, the thing on the bottom of the table is the strongest reducing agent, and the thing on the top of the table is the weakest reducing agent. Okay? So, but we are only talking about the thing on the right-hand side of the arrow. That is the reducing agent, whatever is named on the right-hand side of the arrow. So if we go back and we look at the values a little bit larger over here, okay, you can see that this one here, if we are looking for the reducing agent, whoops, I'm in the wrong place here, so I can't be scribbling. Let's try and scribble over here. If we look over here, this one on the right-hand side here is the reducing agent. And this one on, oops, we're not doing the magnesium either. We're looking at the hydrogen. These two are the reducing agents. So when we answer our question, we have to be looking at only the H2 and the Cu, okay, because those are the things on the right-hand side of the arrow, which are the reducing agents. And so on that little arrow, go back and have a look here in the table. On the little arrow, look, the arrow is going downwards. If you have a negative value, you are a strong reducing agent. So if we have a look at these values and we draw on here, this is increasing strength of the reducing agent. So if we want to compare here, which one has most strength as a reducing agent between the hydrogen and the copper, we say the hydrogen is a stronger reducing agent. Please don't abbreviate anything in these questions. So hydrogen is a stronger reducing agent than copper, because we're just talking about the reducing agents on the right hand side, and therefore copper ions are reduced by the hydrogen, which is your reducing agent. And so if you are the reducing agent, hydrogen, then you say hydrogen is oxidized, because all reducing agents are oxidized. And that means, therefore, where are the electrons going? The hydrogen is pushing out electrons onto the copper ions. So electrons go from the hydrogen all the way to the copper ions, okay? And so therefore you've answered the question. It says the relative strengths of the reducing agents. So to find the reducing agents, you look on the right hand side because they are oxidized, and then you just compare them using the arrows or by using the values. You know that at the bottom of table A is the strongest reducing agent.